In this video we're going to look at some of the different ways that can be used to obtain a sample from a population. Now we often encounter the problem of trying to find some information about a particular population. That is, we want to estimate the value of a population parameter like the mean or the median or the maximum value in the population and so on. So for example, we might want to calculate the mean length of time spent travelling to school by the 1200 pupils at the school. The population consists of all the pupils at the school, and the parameter that we're trying to calculate is the mean travelling time of all of the pupils. Alternatively, we might want to find the proportion of light bulbs of a particular brand that last less than 1000 hours. The population consists of all light bulbs of that particular brand, and the parameter that we're trying to calculate is the proportion of bulbs that last less than 1000 hours. Now, one possibility would be to take a census of the population. That is to ask or test every single member of the population. So for the school case, we would ask all 1200 pupils at the school, how long did you take to travel to school, and then calculate the consequent mean. For the light bulb example, we would have to go through the process of testing every single bulb, by which time, of course, we've spent at least 1000 hours doing that testing, and some of the bulbs will have failed, so won't be of any use any longer. So it will be an exceedingly lengthy process, probably impractical for the light bulbs, and even for the school one, it might well be just too much work to actually ask all 1200 pupils. So a census is when we ask or test every single member of the population, but usually this is impractical. And it's impractical because the collection of the data may destroy the members of the population, but it will certainly destroy some of the bulbs. If we were testing electric fuses to determine what current they will take before blowing, then that would certainly destroy all of the fuses. And the other problem with taking a census of the population is that the population may itself be very large, and taking a census will be both time-consuming and expensive. So in practice we usually take a sample from the population, and it's important to realise that the process of choosing a sample is far from straightforward, because we've got to take care to ensure that the choice of the sample doesn't introduce an element of bias into the sample. So, consider the problem of finding the mean length of time spent travelling to school by the 1200 pupils at a school which starts at 8:30 in the morning. Suppose the investigator, Susan, decides to investigate the travelling times of a sample of 30 pupils. How might her sample be chosen? And there are 5 suggestions here, and what I want to do is to consider whether it seems that this sampling method is fair, or does it introduce some unfairness, which is called bias. So for the first sampling method, Susan simply asks 30 of her friends who attend the school. Now this seems to be problematical to me because her friends may well all be roughly the same age as she is, and may well live close to Susan. So for both of those reasons I would be worried that this method of sampling might well be introducing bias. Now what I'd like you to do now is to pause the video and think about each of the remaining 4 possible sampling methods and make your own comments on these sampling methods and be ready to discuss them at your next lesson. When you've done that, start the video again. Okay then, so what we're now going to have a look at is some of the standard sampling techniques. The first one is random sampling. And a random sample of size n is a sample that is chosen in such a way that every member of the population has the same probability of being a member of the sample, and every possible group of size n has the same probability of being the sample chosen. Now, to choose a random sample of 40 members from a golf club of 652 members, the investigator could number the members from 1 to 652 from the list of members and put 652 tickets with these numbers on into a hat, mix them all up, draw a ticket, make a note of its number and the member that it represents, and then repeat the procedure a further 39 times. It's certainly a perfectly fair process to obtain a random sample. Now, if the investigator returns each ticket to the hat after it has been drawn, then we have random sampling with replacement. And it's possible for a particular member of the golf club to appear more than once in the sample. If, on the other hand, the investigator puts each ticket aside after it has been drawn, then we have random sampling without replacement. And this will ensure that a sample of 40 different members is obtained. Either of these two methods is an acceptable way of producing the sample of 40 members. The second one has the advantage of not including any repetitions, but the first is easier to handle mathematically, both in obtaining the sample and also in dealing with the theory behind the sample. When relatively small samples are taken from large populations, then there is really very little difference between the two methods. Now, another quicker way of getting a random sample of 40 members from the list of 652 names is to use a random number table or to use a random number generator on either a spreadsheet or a calculator. So here's an extract of the random numbers that appear in the formula booklet that you'll have for you and the statistical tables you'll have in your examinations. And we could use this set of random digits by simply taking the last 3 digits of each group of 5 from the first row of the table, ignoring numbers that are greater than 652, and that will then give us some of the club members to appear in our sample. So the first number will give us the member whose number is 024. The second number, 74221, will give us the member whose number is 221. The third number is 721. Well, there isn't a member 721, so we've got to ignore that one. And the fourth number will give us the member whose number is 518. And we can go on along that process all the way along that top row. So the first row of the random digits table gave us the first 6 members of the sample, and we had to throw away 4 of the numbers because they were bigger than 652. So pause the video now and use rows 2 and 3 to obtain some more members of the sample. Once you've done that, start the video again. Using a spreadsheet, using an Excel spreadsheet, the Excel command equals rand between 1 and 652 will give you a random integer somewhere between 161 and 652. So that will give me a random member of the golf club. And if we copy that command across to 40 cells, we'll get a random sample of 40 members taken with replacement. And there's my random sample obtained using exactly that command on a spreadsheet. On the FX991EX calculator, pressing this sequence of keys will give you a random number between 1 and 652. And if you then just press equals each time, you'll generate further members of the sample. The second method of sampling that we're going to look at is called systematic or periodic sampling. Sounds rather complicated to set up, but it's actually fairly simple. To take a systematic sample of size little n from a population of big N, we first of all divide big N by little n, and we suppose that k is the whole number part of the answer, and r is the remainder of the answer. We obtain a random integer between 1 and little n plus k to give the first member of the sample, and we then jump k places through the list to get the next member of the sample, and we keep repeating that process until we have the full sample. So, if we want to get our sample of 40 members from the list of 652 names using systematic sampling, then we first of all do 652 divided by 40, which gives me a whole number part of 16 with a remainder of 12. We then, for the first member of the sample, obtain a random number between 1 and 16 plus 12, which is 28. So we want a random number between 1 and 28 as the first number of the sample. Let's suppose that random number turns out to be 21. Then the full sample will have 21 as its first member. The second member will be 21 plus 16, which is 37. The next member will be 37 plus 16, which is 53. So there are the first 5 members. There are the next 5 members. And here are the remaining 30 members of the sample. So once you've started your sampling process, it's just every 16th member of the list of names. The third method of sampling is what's called opportunity sampling. An opportunity sample is obtained by asking easily available members of the population being considered if they're willing to take part in the research. So, for example, if the survey was aiming to discover the weekly spend on food by households in Bangor, then the survey conductor might just use a sample of 40 customers leaving Morrison's supermarket on a Thursday afternoon. Now let's have a look at some of the advantages and disadvantages of each of these different methods of sampling. So for random sampling, the big advantage of it is there's no bias present in the sampling method. and much of the mathematical theory involved in making inferences from samples assumes that random sampling has been used. However, random sampling can be incredibly difficult and impractical to carry out. It may well be expensive in time and or money, and then the process, even once you've chosen your random sample, of actually being able to interrogate them and get the necessary information from them can be really difficult. For systematic sampling, it's got the advantage that it very rarely introduces inherent bias, and it's close to, but not technically, random sampling. But it's got the same disadvantages that random sampling can have. Opportunity sampling is often very quick, easy, and inexpensive way of choosing participants, but it's very unlikely to be genuinely random sampling, and thus is very likely to introduce bias, which will mean that the results from the sample may be unreliable. So, last two slides in this presentation have got 4 questions for you to consider. So, pause the video here, answer question 1, and then set the video going again, and we move on to questions 2, 3, and 4. So before your next lesson, just think about these 4 questions.